All right, so 6.2, we are factoring trinomials in, this is kind of your standard form, a squared plus bx plus c. Hopefully you guys went through that PowerPoint already. There's a slide that I think is important. This is it, let me get into it. All right, so these are really the 4 different types of trinomials you're going to see, and what I want you looking at is the signs in between the 3 terms. All right, because that's going to determine how you set up your factorization. So you're going to take a trinomial, 3 terms, and factor it into 2 binomials. And if you remember when we had the 2 binomials and we did the factoring, it always gave us back to the trinomial. So now we're kind of working in reverse. All right. The first type is when everything's positive. That's probably the easiest one because both of the binomials are going to be positive. Okay, so you would set it up n plus, and then then we'll get into the how you find the numbers that go into where these question marks are. So that's kind of what I always want to do first is set up what is it going to look like. The next ones I want you to look at is really this one here and the one that last one here. So it's n squared minus 8n minus 48, p squared plus p minus 20. When that last term is negative, okay, like negative 48 here and negative 20 here. When that last term is negative, these are a little bit harder, okay? But when you set them up, that means one's going to be positive and one's going to be negative because that's the only way when we multiply 2 numbers together, a negative and a positive, that we get that negative number there. So if you look at this one, p squared plus p minus 20, that last term is negative. So we know it's going to be p plus p minus. All right, so just keep that in mind. When that last term's negative, we know one's going to be positive, one's going to be negative, and then again, I'm going to show you how to find the numbers that go in there. You look at this one here, okay, and you remember the first one, everything's positive. The last number's positive, last number's positive here too, but that middle, that second term is negative, okay, and what that means is they're both going to be negative. Okay, so if everything's positive, they're both positive. If this term's negative and then this is positive, then these 2 are going to be negative. Because how does that happen? Well, remember, negative times a negative is going to give me a positive number here. So again, it's really these are the 4 different ways you're going to see it. Okay, and just remember, if the last number is positive, that means they're both going to be this, whatever sign of that term there. So if that's positive and this is positive, then everything's positive. If that's positive and this negative, that means they're both going to be negative. And then if the last term's negative, we know one's positive, one's negative. All right, so let's get into it. First example here is x squared. So I'm gonna try to give a couple examples of each kind of circumstance here. So we have x squared plus 8x plus 16. All right, so what I just showed you from that slide is if everything's positive, what we know is our 2 binomials are going to be both positive. Okay, it's going to be x plus because everything's positive. That's the first thing. The next thing you're going to do is if you look at the constant in each situation. So in this problem here, our constant is 16. Okay. And we're going to find all the different factors of 16. And I'm going to work these out kind of a little longer than normal. As we get better with these, I won't be doing this. All right, but as we start out, so when I'm talking about the factors of 16, how do I get, what 2 numbers multiply to give me 16? Okay, and you can always start with 1. 1 times 16, I go to 2. 2 times 8, and in my mind, I'm thinking, does 3 go into it? No, and then the next one, 4 times 4. So these are the 3 different ways that I can get 16. I can multiply numbers together to get 16. Okay, and then the question you ask yourself, well, which one of these, when I add them together, give me this middle number here where we have the 8x. So I'm looking for the ones that add together to give me 8. So they multiply to give me 16. But when I add them together, in other words, when I go 1 plus 16, what do I get? I get 17. When I go 2 plus 8, I end up getting 10. When I do 4 plus 4, I get 8. And that's the one I wanted, because I wanted when I add them together, I get 8. So if you find those two and you know that these are the two, it's 4 and 4, and this one they happen to be the same, those are the numbers you're putting in the middle. Well, why does it work like this? What is happening here? So let's go back and remember, if I was multiplying these together, okay, so I would do x times x and x times 4, so I would get x squared plus 4x, right? And then I come to the second term and I do the same thing, right? 4 times x gives me 4x, and then 4 times 4 gives me 16. So remember, I had two numbers that multiply together to give me this last term, right? And then I added these two terms together in the middle to get me that 8x. So it was like they multiply, 4 times 4 multiplies and give me 16. And when I add 4 plus 4 together, it gives me 8. So that's kind of what we are going to do. We're going to look at our, always start with that last value. Think of the factors of that. And so we know it's going to be, for the most part, one of these three. Now, there are some circumstances where it won't be any of those, and we call that a prime. But I think there's one problem out of the 20 that would be a prime, and it's very obvious. Okay, so don't think that a lot of them are going to be prime, because they're not. But once you get these factors, then we figure out how do I know which one of these three combinations that it is. It's the ones that will add together to give me the middle value. And then once you find them and you already know how it's set up, you just put it in there. So let's look. I'm going to just do another one with them both being positive. Okay, so we look at that last value of 50. Now there's a lot of, the bigger the number, the more factors are going to be. So you got 1 times 50, 2 times 25, not 3 and 4, 5 times 10. Just in this case, there's just not a whole lot of, oh, actually, yeah, 2 times 25. So those are the three ways that I can get 50. And again, they're both going to be positive. Should have probably done that first. Since everything's positive, it's going to be x plus. And then which ones, when I add them together, give me 15. Okay, if I add these together, I get 51. This gives me 27. This gives me 15. So I know it's the 5 and the 10. I put the 5 and the 10 back. And again, you can check this by distributing it all out if you want to do that. But you'll get, once you do that, you'll come back to that. So this would be the answer they are looking for there. All right, so let's look at another one. All right, so this is kind of the other one that I think is a little bit easier. It's when that term's negative, but that term's positive. And remember, when that's the case, we know they're both going to be negative. So we're going to have two negative values. Both our factors are going to be negative. But when I multiply those two negatives, it gives me that positive. So again, I'm looking at that. Start with the 20, the different ways to get 20. 1 times 20, 2 times 10, 4 times 5. And those are all the different ways. And again, in this case, we know they're both going to be negative. And when I add these together, I get negative 21, negative 12, negative 9. Well, which one did I want to use? The one that obviously gives me the negative 12. So it's going to be a -2 and a -10. So -2. You just plug those values in. I already have the negative signs because I knew that's how they were going to go. And they're both going to be negative. And again, -2 times -10 gives me the +20. -2r when I multiply these two, and the -10, -2r, -10r would give me the -12r. So we'll do another one with them both being negative. Negative and then a positive. So when I set it up, I know they're both negative, and you could always kind of peek back at that one slide that I reviewed with you guys. Factors of 40. Again, bigger the numbers usually means more different possibilities. Again, I'm sorry, both negative. -2, so 2 times -20. 3 doesn't go into 40. -4 times -10. And then -5 times -8. So in this one, we had 4 different combinations. I'm looking for the one that would add together to give me -13. This gives me -41 when I add them together, -22 when I add them together, -14 when I add them together, -13. Again, I want the one that gives me the -13. So it's -5 and -8. Plug those values in. -5, -8. All right, so the next type of problem we are going to be looking at, slide this down a little bit. X squared minus 2x, okay. When we have that last value, so think back to the examples we've already done. Okay, we did 2 with everything positive, so we knew when everything's positive, our 2 binomials are going to be positive. When that middle term's negative, but the last number is positive, that means they're both going to be negative. Well, originally to set these up, it's x squared minus 2x minus 48. If that last term is negative, what that tells me is that when I set this up, one's going to be positive and one's going to be negative. The reason why this is going to be a little more work for me is instead of having these where they're both positive, both negative, or all positive, all negative, one's going to be positive, one's going to be negative. So it actually can, the one number that's positive could be positive or negative. So in other words, there's actually 2 different ways you can write each kind of example that you find. And it's easier, again, if I just start giving you examples. So let's think of -48. And there's going to be quite a few different combinations on these, okay? So in other words, to get -48, I can multiply -1 times a positive 48, or I can do +1 times a -48. And that's what I'm saying. Each different way you find it, the negative can be on either number. So there's 2 of each kind of combination is what I'm trying to tell you. So we know -2 times, what was that, 24? Positive 24, or +2 times -24. Slide this over a little bit. -3 times, I think it's 16. And then +3 times -16. -4 times +12. +4 times -12. Running out of room, so I'm gonna come up here. And again, if you're not good with these, you can just divide these numbers in to make sure that, because they gotta go in perfectly. The next one, -6 times a +8, or +6 times a -8. And then I think we are done. So again, when that lasts, that's why those are a little tricky, because it gives you, like I said, You're just going to have double the combinations. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we have 10 different possibilities of ways that will multiply to give me negative 48. So what I'm trying to figure out is which one of these combinations add together to give me the negative 2. Okay, and again, it's got to be a negative 2. So again, if we add all these up, this would give me 47, negative 47, 22, this one gives me negative 22, 13, this gives me negative 13, this would give me a positive 8, this one gives me negative 8. So you see, you have a positive way or a negative way. This gives me positive 2, this gives me negative 2. Again, which is the one I wanted? The one with a negative 2. So I know my combination is 6 and negative 8. So just make sure you put these in the right spot. 6 would be my positive value, so I put that where the plus is. My 8 is the negative, so that's where that would go. Again, it's an easy check. 6 times negative 8 gives me negative 48. Negative 8 plus 6 gives me negative 2. So we will do some more with that last number being negative. All right, so this one's a little bit easier because our last number is kind of a small value. It's negative 2. Probably should have started with that example. There's just not a lot of different ways that I can get negative 2, right? You got 1 times negative 2 or negative 1 times positive 2. That's it. It's just basically 2 different ways I can get negative 2. So which one of these is going to give me a positive 1? Well, when I add positive 1 and negative 2, I get a negative 1. And when I add negative 1 with positive 2 here, I get a positive 1. And again, I probably should have told you, we know that that's a 1 there. So which one of these combinations gives me the plus 1? Well, it's negative 1 and positive 2. And again, I forgot to set this up, but again, this is positive. The last, we just know, it doesn't really matter what this is. If this last value is negative, it's going to be an x plus and an x minus. And then where goes, what goes where? Well, the 2 is the positive, so you put 2 at the positive. The 1's your negative. There you go. So you see why we kind of like them when that last number is positive. It's a little less work. All right, and let's look at another example there. Okay, x squared plus 3x minus 28. See that last value is negative. We know that means one number's got to be positive, the other number's got to be negative. So we looking at the factors of negative 28. So we start with 1. 1 times negative 8, or negative 1 times positive 28. Negative 2 times a positive 14, or positive 2 times a negative 14. Negative 4 times 7, or positive 4 times a negative 7. So those are, again, our different combinations. We're going to start kind of skipping ahead a little bit, or maybe skipping some steps, because we know what we're doing next. What do these values add up to? Actually, I'll do it one more time. We're adding 1 and negative 28. It gives me negative 27. This gives me a positive 27. This gives me a positive 12. This gives me a negative 12. This gives me a positive 3. This one gives me a negative 3. So which one of these combinations is the one I want to use? I want to find the one that gives me a positive 3. If you get good with these, you can do these kind of in your head. You don't really have to write down all the factors. But if you got to write them down, that's fine as well. Again, just make sure we put these in the right spot. The 4 is the negative. The The 7 would be the positive. And there we go. All right, so they give you some kind of weirder, strange problems because I just want to make sure you understand what you're doing. Okay. So if we look at this problem here, the way this problem is different than some of these other ones, all it is the way they order that problem. It is not really in descending order where our highest exponent is first. You're used to seeing your t squared first. So all you got to do is rearrange this in the proper order. And now it looks like, you know, these other problems we're used to. Looking at the negative 44, factors of negative 44, 1 times negative 44, negative 1 times 44, 2 times, what's it, negative 22, negative 2 times positive 22, negative 4 times 11, positive 4 times negative 11. I think that's it for negative 44. And again, which one of these would add up to a positive 7? And we know it's negative 4 and positive, negative 4 times positive 11. And again, we should have had t plus, t minus, because we knew that last value was negative. That's how we know how to set it up. The positive value would be 11. The negative value would be 4. And again, if you switch these around, if you do this t minus 4 times t plus 11, doesn't matter. The way you set up these binomials, that's not important. All right, next example. We should like this problem because everything's positive. The thing that makes this a little bit different is we have an x squared, we have xy, and then we have a y squared. Okay, and all that means is when I set this up, it's going to be x plus some number times y, and x plus some number times y. Okay, and so we got to find the numbers that go in here. Okay, but that's how we're getting the y squared, and that's how we're getting the x squared. And we know that xy is when I multiply x times whatever that number is, it's going to be whatever that number, and then xy following it. Okay, so just kind of remember that's how you set this up. We still got to find the numbers that are going to go in these spots here. Still looking at that last value of 35. 1 times 35, there's not a whole lot of combinations on 35. And again, since it's positive, they're both going to be positive values. That's what we like instead of the negatives where we had to switch every, find 2 different ways for each number. So which one's going to add together to give me 12? It's pretty obvious. 5 into 7. So that's all I was saying. That's kind of what goes here. So this is just really x plus 5y. Don't forget the y. And x plus 7y. All right, we got a few more to go over. One of the things I really didn't tell you guys, but it's really the first thing you have to do when you're doing these trinomials, okay, is factor out that GCF. And all the examples we've done prior, you didn't have to factor out a GCF because there wasn't a number in front of that x squared. But if you notice in this problem here, I have a 2 in front of it, and you notice all these are even numbers. So what that tells me is I got to factor out my GCF before I can factor that trinomial. In other words, what's my great GCF of 2, 16, and 30? Well, the GCF would be 2. In other words, I got to factor out a 2 first. So when I factor out a 2 out of this is what the trinomial turns into. Okay, I'm dividing 2 out of these 3 terms. So I get x, I got the 2 out here, and then I got x squared plus 8x plus 15. Now I got to factor this. We know this, so I'm still going to have the 2 out in front. And then it's going to be x plus because, again, everything's positive, so I know my factors are going to be positive. 15 is one of these numbers where there's not a whole lot of combinations. 1 times 15, 3 times 5. So I'm looking for the ones that add together to give me 8. And we know it's 3 and 5. Okay, so just you had to factor out that GCF first and then factor the trinomial. Now this one's fun because this is one with a t. Not only am I going to have to factor out a number for my GCF, I also got to factor out variables. And how do I know that? Well, first of all, I look at the coefficients, 2, 10, and 12. They're all even. So I got to factor out, I know at the very least I can factor out a 2, and I'm just being that 2 is there, I'm gonna, part of my GCF is gonna be 2. Okay, the next thing I know, I see a lot of t's here. So we're used to like a constant at the end, right? Well, what can I factor out? Which variable can I factor out of all 3 of these? And they all have a t. The most t's I can factor out is whatever the smallest value is, 5. So t to the 3rd. So that's my GCF. That's what I factor out of each of these terms. So in other words, I'm taking out a 2t to the 3rd from each of these problems here. So this would leave me, the 2's would cancel out. There's 5 t's. I'm taking out 3 of them. That leaves me t squared. 10 divided by 2 gives me a 5. And then there was 4 t's. I took 3 out, so there's 1 left. Here, all the t's are gone, and I'm just doing 12 divided by 2, and that would give me a positive 6. So let's set this up, because now we're going to factor that trinomial. See a minus there, but a positive there. What that tells me is both of these are going to be negative. It need to be two negative numbers that give me, multiply to give me a positive value, but when I add them together, they give me a negative value. So think of 6. In other words, they both got to be negative. So we're going to go -1 times -6. And then -2 times a -3. Which one of these multiply together to give me, well, we know they both multiply to give me a positive, but which ones will add together? When I add them together, give me a -5. When I add -1 and -6, that gives me a -7. But when I add -2 and -3, that's what gives me the -5. So we know it's -2, -3. So again, it's just check to see, you're going to have to factor out a GCF if there's a value in front of that first variable. Okay, or if there's, t to the 5th, t to the, they all have a t or something, or an x, they all have an x, you got to factor something out. So it looks more like our traditional examples, the first few examples that I told you that we did. And then my last example is going to give you an example of an answer that is prime. And like I said, I only saw 1 out of the 20 problems. So maybe you'll have 2, but I'm not sure. So you have this trinomial that they want to factor. It's x squared plus 13x plus 2. So again, we look at the last number, which is 2. And we know what are the ways to get 2? Well, only 1 times 2. What does 1 plus 2 equal? 1 plus 2 equals 3. We are looking for 2 numbers that will multiply to give me 2, but will add together to give me 13. There is no combination, because this is the only combination that we can get to with, and that gives us 3. So when you get something like this, that means it's a prime factor. That means you cannot factor that, okay? So if you can't factor it into 2 trinomials, into 2 binomials, I mean, so that's where you would say this example here is a prime. All right, so a lot going on in 6.2. Factoring trinomials is something that's new, that takes a little bit of an adjustment. something we do spend a lot of time on. And I know the next, this is, you know, an important section that you definitely need to work on. If some of these are a little confusing, like I said, just practice do, you know, once you solve them, ask them, give me another example problem, and you can just keep practicing these problems until it gets easier for you.